How John Deere compact tractors are made inside the tractor factory, full process. Intro. What does it take to build one of the most trusted compact tractors in the world? A machine capable of mowing fields, moving heavy loads, digging trenches, clearing snow, maintaining landscapes, and helping farmers, contractors, and property owners complete demanding tasks every single day. Today, we're going inside a modern John Deere tractor factory to witness the incredible process of manufacturing compact tractors from the ground up. From raw steel and precision machined engine components to robotic welding systems, advanced paint facilities, hydraulic systems, and rigorous quality testing, every John Deere compact tractor undergoes an extraordinary manufacturing journey before it ever reaches a customer. For nearly 2 centuries, John Deere has been one of the most respected names in agricultural and construction equipment. Its iconic green and yellow machines are recognized across the world as symbols of durability, reliability, and innovation. Compact tractors may be smaller than massive agricultural machines, but their manufacturing process is no less impressive. Every tractor must deliver years of dependable performance under tough working conditions. Inside the factory, engineers, technicians, machinists, welders, assembly specialists, and quality inspectors work together with remarkable precision. Heavy steel arrives daily, automated machines shape components, robots weld frames together, workers install engines, hydraulics, and electronics. And every few minutes, another compact tractor moves one step closer to completion. The scale is impressive, the engineering is fascinating, and the attention to detail is extraordinary. So sit back, relax, and let's go inside the John Deere Tractor Factory to discover the complete process of how compact tractors are made. Chapter 1: Designing a John Deere Compact Tractor. Long before manufacturing begins, years of engineering and product development take place behind the scenes. Designing a compact tractor involves balancing power, durability, versatility, fuel efficiency, operator comfort, and ease of maintenance. Engineers begin using advanced computer-aided design software. Every component is modeled digitally. The frame, the drivetrain, the engine, the hydraulic system, the operator station, and every attachment interface. Computer simulations test structural strength, vibration resistance, cooling performance, and operating efficiency. Engineers analyze how the tractor performs under heavy workloads. Whether lifting loads with a front loader, operating a mower, or pulling implements through difficult terrain, the machine must perform reliably. Prototype tractors undergo thousands of hours of testing before entering production. Only after rigorous evaluation is the design approved for manufacturing. Now the journey begins with raw materials. Chapter 2: Receiving raw materials. Every day, trucks arrive carrying enormous quantities of materials and components. Steel plates, steel tubing, cast iron parts, hydraulic components, electrical systems, engine parts, fasteners, and thousands of additional items. Each shipment is inspected carefully. John Deere maintains strict quality standards. Incoming materials must meet exact specifications before entering production. Large computerized inventory systems track every component. Modern manufacturing relies on precise coordination. Parts must arrive at the right location at exactly the right time. Once approved, materials move to their designated production areas. The first major stop is the fabrication department. Chapter 3: Fabricating the tractor frame. The frame serves as the backbone of the tractor. It supports the engine, transmission, hydraulic systems, and operator controls. Fabrication begins with heavy-duty steel. Large laser-cutting machines shape steel plates into precise components. Computer-controlled equipment ensures exceptional accuracy. Steel sections are then formed using press brakes and specialized machinery. Each component is manufactured according to strict engineering requirements. Strength and durability are critical. Compact tractors often operate in harsh environments. Mud, dust, heavy loads, uneven terrain, and extreme weather conditions. The frame must withstand years of demanding use. Once individual parts are prepared, they move to welding stations. Chapter 4: Robotic Welding and Frame Assembly. Inside the welding department, sparks illuminate the factory floor. Robotic welding systems and skilled technicians work together to assemble the tractor frame. Large fixtures hold components in precise positions. Robots perform many of the welds with exceptional consistency. Human welders handle specialized operations and perform inspections. Every weld contributes to the tractor's structural integrity. Quality is essential. Defective welds could affect long-term durability. Advanced inspection systems verify weld quality continuously. The completed frame undergoes dimensional inspections to ensure it meets exact specifications. When approved, it moves to the surface preparation area. Chapter 5: Surface Treatment and Painting. Before painting begins, the frame and metal components undergo extensive preparation. Cleaning systems remove oils, dust, and contaminants. Surface treatments improve corrosion resistance. Tractors frequently operate outdoors in challenging environments. Protection against rust and corrosion is critical. After preparation, components enter the paint facility. John Deere's iconic green and yellow colors are applied using advanced painting systems. Primer coatings provide adhesion and durability. Robotic paint systems apply uniform coverage. Multiple layers create a durable finish capable of withstanding years of exposure. The painted components then pass through curing ovens. Heat hardens the coating and ensures long-lasting protection. The famous John Deere appearance is finally revealed. Chapter 6: Engine Manufacturing. While frames are being prepared, engines are being assembled elsewhere in the production network. Compact tractors require efficient and durable power plants. Most modern John Deere compact tractors use advanced diesel engines. Engine manufacturing begins with precision machined blocks and cylinder heads. Computer-controlled CNC machines create components with microscopic accuracy. Workers assemble pistons, crankshafts, camshafts, fuel injectors, and cooling systems. Modern diesel engines must provide excellent fuel efficiency while delivering strong torque at low engine speeds. Every engine undergoes extensive testing. Engineers verify power output, fuel consumption, emissions performance, and reliability. Only approved engines continue toward final assembly. Chapter 7: Transmission Production. The transmission is one of the most important systems in a tractor. It transfers power from the engine to the wheels and implements. Modern compact tractors may use hydrostatic or gear-driven transmissions. Precision machined gears, shafts, bearings, and housings are assembled carefully. Hydraulic components are integrated. Electronic controls may also be installed depending on the model. Each transmission undergoes testing before approval. Smooth operation and reliability are critical. A tractor often operates for thousands of hours during its lifetime. The transmission must perform flawlessly under demanding conditions. Chapter 8: Axles and Drivetrain Components. The drivetrain allows the tractor to convert engine power into useful work. Front and rear axles are assembled using high-strength components. Differentials, drive shafts, and reduction gears are installed. Many compact tractors feature four-wheel drive systems. These systems improve traction in challenging conditions. Engineers design the drivetrain to handle heavy loads and difficult terrain. Every component undergoes inspection before installation. Durability is essential. The tractor must perform reliably for many years. Chapter 9: Hydraulic System Assembly. Hydraulics are the muscles of a compact tractor. They power loaders, backhoes, implements, and lifting systems. Hydraulic pumps are assembled carefully. Valves, cylinders, hoses, and reservoirs are prepared for installation. Modern hydraulic systems generate tremendous force. They allow compact tractors to perform tasks far beyond what their size might suggest. Each hydraulic component undergoes pressure testing. Leaks are unacceptable. Reliability is critical. Once approved, hydraulic systems move to the assembly line. Chapter 10: Chassis Assembly. Now the tractor begins taking shape. The painted frame arrives at the main assembly line. Technicians install axles first. Suspension and steering components follow. The transmission is mounted carefully. Hydraulic lines are routed throughout the chassis. Fuel tanks are installed. Brake systems are added. Each workstation focuses on specific tasks. Workers follow detailed assembly procedures to ensure consistency and quality. The bare frame gradually transforms into a recognizable machine. Chapter 11: Engine Installation. One of the most exciting moments in production is engine installation. Large lifting equipment positions the diesel engine above the chassis. Technicians lower it carefully into place. Mounting brackets secure the engine. Cooling systems are connected. Fuel lines are attached. Electrical systems are integrated. Exhaust components are installed. At this stage, the tractor finally gains its source of power. The machine is becoming increasingly complete. Chapter 12 Operator Station Assembly. Comfort and usability are important features of modern compact tractors. Technicians begin assembling the operator station. Floor platforms are installed. Control pedals are mounted. Steering systems are connected. Seats are added. Depending on the model, tractors may feature open operator stations or enclosed cabs. Controls are positioned carefully to improve ergonomics. Operators often spend long hours working. Comfort helps reduce fatigue and improve productivity. Chapter 13 Electrical Systems and Technology. Modern tractors contain far more technology than many people realize. Technicians install wiring harnesses throughout the machine. Electronic control units manage engine performance and various operational functions. Digital displays are installed. Sensors monitor temperatures, pressures, fuel levels, and system status. Lighting systems are connected. Safety switches are tested. Some models include advanced monitoring systems and electronic controls for attachments. Every electrical connection undergoes verification. Reliability is essential. Chapter 14 Wheels, Tires, and Attachments. The tractor now receives its wheels and tires. Different tire types are available depending on the intended application. Agricultural tires, industrial tires, or turf tires. Large assembly equipment mounts the wheels carefully. Technicians verify alignment and torque specifications. Attachment systems are also installed. These may include front loaders, quick attach systems, rear hitches, and power takeoff components. Versatility is one of the key advantages of compact tractors. A single machine can perform many different tasks. Chapter 15 Fluid Filling and Initial Startup. Before testing can begin, the tractor receives essential fluids: engine oil, coolant, hydraulic fluid, transmission fluid, and fuel. Technicians connect diagnostic equipment. System checks begin. Then comes one of the most exciting moments in the factory: the first engine start. For the first time, the tractor operates under its own power. The diesel engine comes to life. Hydraulic systems activate. Displays illuminate. Sensors begin communicating. Engineers monitor every parameter carefully. Any abnormalities are corrected immediately. Once approved, the tractor proceeds to testing. Chapter 16 Quality Control Inspection. Quality control is a major priority throughout production. Every tractor undergoes detailed inspections. Technicians verify assembly quality. Fasteners are checked. Hydraulic systems are inspected. Electrical systems are tested. Paint quality is examined. Engineers review diagnostic data. Measurements confirm proper alignment and assembly. Every tractor must meet strict standards before advancing. The goal is simple. Customers expect legendary John Deere reliability. The factory works hard to deliver it. Chapter 17 Performance Testing. Before leaving the factory, every tractor undergoes operational testing. Engine performance is verified. Hydraulic functions are tested. Transmission operation is evaluated. Steering response is checked. Brake systems are examined. Technicians operate the tractor under controlled conditions. Many factories use specialized test tracks. These allow engineers to evaluate performance under realistic conditions. The machine must demonstrate proper operation before receiving approval. Chapter 18 Final Inspection and Detailing. After performance testing, the tractor undergoes a final inspection. Technicians examine every visible surface. Labels and decals are verified. Protective covers are installed where necessary. The machine is cleaned thoroughly. Final documentation is completed. Inspectors perform one last review before approval. Only tractors meeting every requirement receive authorization for shipment. The finished machine now stands ready for service. Chapter 19 Shipping to dealers worldwide. Once approved, tractors move to shipping areas. Rows of completed John Deere machines await transportation. Each tractor is assigned a destination. Some remain in domestic markets. Others travel internationally. Specialized transportation systems move tractors efficiently. Trucks, trains, and shipping containers help deliver machines to dealerships around the world. Soon these tractors will begin helping farmers, landscapers, contractors, and property owners complete important work. Conclusion. From raw steel and precision machined components to advanced diesel engines, hydraulic systems, robotic welding, detailed assembly procedures, and rigorous testing, the production of a John Deere compact tractor is